Good day, students. Hope you are keeping well. By this time, there should not be any pending activities in the discussion forum. If for any reason, you have not submitted the activities, I suggest you that you complete them before proceeding further, as you will be learning computer tools that are used by engineers. If you procrastinate too long, you might not have enough time to do all the tasks or to do them all well for a good score. Okay, let us start this week's presentation. MATLAB is a special-purpose language that is an excellent choice for writing moderate-size programs that solve problems involving the manipulation of numbers. The design of the language makes it possible to write a powerful program in a few lines. The problems may be relatively complex, while the MATLAB programs that solve them are relatively simple, relative, that is, to the equivalent program written in a general-purpose language, such as C++ or Java. As a result, MATLAB is being used in a wide variety of domains, from the natural sciences, through all disciplines of engineering, to finance, and beyond, and it is heavily used in industry. Hence, a solid background in MATLAB is an indispensable skill in today's job market. Please note down the simulation links that you can use for live demonstration. In this session, you will learn fundamental computer programming concepts such as variables, control structures, functions, and many others. You will learn about various data types and how to handle them in MATLAB. You will learn the powerful support MATLAB provides for working with matrices. You will learn how to start MATLAB and will familiarize ourselves with its user interface. You will learn how to use MATLAB as a sophisticated calculator, learn about syntax and semantics. You will see ways in which MATLAB provides help. Finally, we will learn how to create plots in MATLAB. In the classrooms, you will be using MATLAB software. Outside classroom, you can practice using web-based simulation tool that is available in the link shown in this slide. A graphical user interface, GUI, is a type of user interface through which users interact with electronic devices via visual indicator representations. In this slide, you are seeing the MATLAB interface showing the actual working space. There will be a slight variation in the interface depending on the version that you use. The workspace contains variables that you create or import into MATLAB from data files or other programs. You can view and edit the contents of the workspace in the workspace browser or in the command window. For more information, see Create and Edit Variables. Workspace variables do not persist after you exit MATLAB. You will also be seeing the interface for the simulation tool. MATLAB Registered is a mathematical software that can be used to solve a wide range of engineering problems. Before the introduction of MATLAB, engineers wrote their own computer programs to solve engineering problems. Built-in functions of the software are useful. MATLAB is also versatile enough that you can use it to write your own programs. In this slide, you are seeing the screenshot of the MATLAB simulation link. Though you see a different screen when compared with MATLAB tool, the functionality is still the same. You can follow the same syntax that will yield the similar outcome. Now I want you to type the URL shown in the slide. After opening the simulation tool, I want you post the screenshot in the Blackboard discussion forum by creating a new thread. In this activity, you will be using three variables, A, B and C. Variable A is assigned with value 3. Variable B is assigned with value 5. Variable C is assigned with the total value of 3 plus 5, which equals to 8. In this video clip, you will see how the statements or instructions are typed in the simulation page. You will observe the line numbers automatically incrementing after every line of statement. Once the lines of instruction is typed, move the mouse pointer over Execute as shown and click it once. Now type the answer that you see in the result space in the comment section. The semicolon at the end of a statement acts to suppress output, to keep the program running in a quiet mode. The third statement, C equals A plus B, is not followed by a semicolon, so the content of the variable c is dumped as the output. You will adhere to the similar steps to do the following exercises. Before proceeding further, you must be able to understand the statements ending with a semicolon. Semicolon indicates end of statement. However, if you want to suppress and hide the MATLAB output for an expression, add a semicolon after the expression. For example, consider the expression shown in the slide. When you click the execute button, or type Ctrl+E, MATLAB executes it immediately and the result returned is y equals 8. You will not see the expression x equals 3 as it is suppressed by the semicolon operator. Now let us proceed with the activities. In the workspace, type the expressions shown and hit execute button. Think of the two variables a and b as two buckets labeled a and b. The first statement puts the number 3 into bucket A. The second statement puts the content of bucket A into bucket B, such that we now have 3 in bucket B. The content of bucket A remains unchanged after this action. The third statement dumps the content of bucket B, so the final output is 3. Now type the expression shown and hit the execute button. To explain the output, see the right-hand side of the third statement includes all 4 of the basic arithmetic operators: plus, addition, subtraction, asterisk, multiplication, and slash, division, in their usual meaning. It also includes the symbol, caret, which means to the power of, so b caret 2 means, the content of b, to the power of 2, i.e., 9 squared equals 81. The right-hand side of that statement is first evaluated. RHS equals 2x3 plus 92 to 3x9 plus 9/3, 10 equals 53. The content of right side expression is now 53, is then assigned to the variable c in the left side. Since this statement is not followed by a semicolon, the content of c is dumped as the final output. Now type the expression shown in the slide. To explain the outcome, the value of the variable a is 3 after the first statement. In the second statement, the right-hand side is first evaluated to be 3 plus 1 equals 4. This value is then used to replace the old content of a, so a becomes 4 instead of 3. Let us see the demonstration of the printf function. The output in the display is the word hello. The print function allows you to write information to the screen for the user to view. This very important when user interaction is involved. The F in printf stands for formatted. This means you can format how the data is printed in such a manner as to make it easy to read. Let us see how to add comments that are useful for future reference for programmers. The % symbol, %, is used for indicating a comment line. For example, consider the above statement. Anything that follows the % symbol will not be executed. You can also write a block of comments using the block comment operators. The MATLAB editor includes tools and context menu items to help you add, remove, or change the format of comments. Type the set of statements as shown. Hit the execute button to get the output. If you observe the output, the command printf is for formatted output, using the format specified in the first string in the parentheses. The %4u, 4-digit integer, and %6.4f, real number that preserves 4 digits too. The right of the floating point, are the format for the variable, s, for output. The sqrt in the fourth statement is the intrinsic function for square root. With this we come to the end of the session. Please make sure that you submit all the completed activities in the appropriate discussion forum. You will see MATLAB activities posted in Blackboard. You can start doing all the activities. Thank you for your time. Be safe and bye for now.